See it online?
If you see it on there, they will see it.
Excellent. It's looking good. Okay, so the title is just a very quick one: Life, the Universe and Everything, which those who will remember Hitchhiker's Guide to the Galaxy, and just to say this is the last reference to all of that, apart from, which was the other great thing from the Hitchhiker's Guide to the Galaxy, its most famous 2 words. So, very, very quick overview of myself, my background. Then really what I want to do is to talk more about the more exciting things, which is the strategies, the vision, the work we're doing in Southern on the conductor rail system. But one of the reasons I put this in is I've been very lucky in my career. It's about 39 years now, of working in loads of different areas of the business. And one of the things that I often speak to people about is silos, and actually trying to make sure we knock those silos down and don't get stuck in a silo. And for me, that's really important. It doesn't matter whether people are in projects for their life. You always need some people that do that. But if you get different bits of experience from all around the business, from asset management, from engineering leadership, from maintenance, I believe it really helps build up that background, that experience, that knowledge that helps in the future when hopefully people get to higher levels of engineering leadership. And just to say, yes, I'm an E&P engineer, and we run an electrified railway, but to me the important thing is we need all the asset groups, we need all the parts of the infrastructure, and then the train operating company, then operations, to come together to make the system work. So we've got a bit of track, a bit of signalling, a bit of E&P, a bit of buildings and civils, line side and drainage. And then of course there's electrical supply and non-traction, because we run an electric railway even on diesel routes because of all the signalling. So there's no power, we tend not to be able to run trains. And then 2 other really key things as well, which are operations and maintenance. We need all of these things to be there to work together to get a successful train service, because otherwise it fails. So, you know, this morning when I was coming to work, point of failure, it doesn't matter whether E&P was there or not. We couldn't run the train service we want to do for our customers this morning. So, in Southern, it's great to be able to talk to people. Sometimes I think we've excluded ourselves from Southern from the greater conversations. People always talk about OLE engineering, they talk about WEP, they talk about that side of the electrification business. And actually, sometimes we've probably not, it's our own fault, partly we're in the shadows, if you like. Having opportunities like today is fantastic, because hopefully today you'll see there's loads of really exciting innovation. We are pushing, we're developing with devolution, we're actually taking the grasp, we're not actually being victims, we want to drive our own future. And because of that, we've come up with a 6-point vision of all the things that we are trying to achieve in Southern. So the first, and some of these, I've got some more slides later to go through in a bit more detail, but just at a high level. So as a vision, we don't want to have any electrical accidents in Southern. So we've got a safer, smarter isolation programme, which is probably about 65% complete in Wessex, and at the end of this control period, it'll be about 30 or so % in Sussex and a bit less in Kent. Which means people don't have to go out on track to operate, often operate hook switches. We don't have to fit short circuit straps. It's all done from a place of safety, right by an access gate, and with fixed bits of equipment. So we take away train risk, we take away electrical risk. Where we do have straps that remain to be fit, we want to put what we call designated strapping points, which is just like a plate on the sleeper, so people don't have to estimate where 37 miles 14 chains is. There's actually a point on the track marked where the short circuit strap goes. We want to improve safety in train care depots. We want to, by changing walking routes, by changing layout, so that we can actually better fit safety by design in those environments. Where possible, we want to remove conrail floaters, which are the short lengths of conductor rail and crossovers and things like that, that can be a risk if people don't know they're there and don't understand in terms of planning when they need to be switched off. Now, just bear in mind this is a vision because we want zero affecting failures. Again, that's the right vision. How long are we going to get there? It's going to be a long time. But what we're trying to do with modernising maintenance is taking the assets, taking the maintenance interventions we do, and trying, instead of saying we're just going to do less, we're trying to change it to be the right intervention in the right place at the right time. So sometimes that means pushing maintenance further back. Sometimes it means doing maintenance in a different way. Sometimes it means bringing in different techniques, using new technology, using innovative sort of condition techniques to try and help us to determine the health of the network. We want more train-borne monitoring. So we've already got the yellow machine that runs with PLPR3 that does gauging of the conductor rail. So it does wear gauging, it does height, and it does lateral displacement. And that's massive for us because we then don't have to have people going out with gauges on the track measuring. And of course, the other great thing, being a system, the train actually measures the system as a loaded system. So the track's loaded, so if there's voiding under the track, we see that impact on the conrail. And also if the conductor rail slightly tipping or whatever it is, we can pick up those dynamically rather than just in a static situation. We want to put more monitoring on service trains, not to give that level of detail, but we want to be able to pick up what I call impending doom alarms. Are you trying to pick up things where there's much bigger forces on tubing? It could be a piece of troughing, left failure gauge, it could be a conrail joint that's started to suffer. But it's all about predicting and trying to get in and do remedial action before the actual failure takes place. And of course, with life, it's never quite as easy about getting all the money we need for renewal. So it's about what refurbishments, same sort of conversations in track and all the other disciplines about what can we do to try and get the best use of our money to be able to minimise that risk as best we can by being smart with refurbishments, with looking at maintenance and other interventions. We want to be the DC third rail industry leader. So we want to grasp that. We've probably got 96% of the DC third rail system in Southern. We don't want to ignore or forget the others. We want to help support the LNW for the Euston Watford, Merseyrail and Eastern on Drayton Park Moorgate. We already do that. So why don't we become the centre of excellence? We've got all the engineers in Southern, we've got the experience in Southern, and what we want to try and do is to say, why do we need to duplicate that in the Tech Authority? Why not actually have that in Southern? So we want to look at power generation. We want to look about renewable energies. We want to talk about solar. We want to talk about energy storage. We want to talk about new electrification, be that a full electrification or actually using a hybrid diesel or battery and electrification, whatever it is, whatever is the most overall economically but ecologically sound as well. So, for example, there's a number of battery and fixed electrification schemes being looked at the moment for infill electrifications, all with the intention of removing diesel traction. Fit for the future. So sometimes, if when we've got a fixed infrastructure, it's got a set capability, a set capacity. If someone wants to do something completely different, we need time to evaluate the requirements against what our network can currently do. So, as an example, running 20 trains an hour instead of 10, there's going to be an impact on our infrastructure in terms of capability of equipment, grid supply points, rating of electrical equipment. Sometimes, in the past, that might have been done, and within a year's notice, we can say, yeah, that's okay. But we're pretty much at a point where we're eking out the last electron from our system. So if someone comes along like that, we need time to be able to model, to be able to determine what we need to do. So we've got time to build the enhancement to enable the outputs. Electrification is all about supporting the service. It's not about what it does itself. If we don't support the service, we haven't done the right thing, or the requirements of what people want in terms of train service, train pattern, train lengths. But we need that visibility. We want to embrace new and novel technologies. So we are looking always about, we're still looking at new types of conductor rail. We're looking about energy storage. We're looking at ways of making ourselves more efficient. And we talked about the new infill technology. And the other one is about people. So I always talk about the conveyor belt of life. I'm getting near the end of that conveyor belt in terms of my career, as a number of other people are in Southern EP. We need to make sure that there are enough good people getting on the start of the conveyor belt so that we can download some of that knowledge and experience and make sure that they become the next generation of really good, solid engineers as we go forward. So we need the right training and competency frameworks. We need to be able to sometimes over-recruit if we know we've got an impending number of people retiring. We need to have that visibility because you can't pick a DC engineer up off the street. They're not there. We don't, sometimes there is a level of equivalence with the electricity industry, but even that is a real struggle these days. In the electricity industry, the DNOs, the National Grid, they're also all struggling for power engineers. So we need to grow and develop our own. So a little bit about the safer, smarter, faster isolation process. So what we've got there it is, if you like, the old way that we used to protect the conductor rail from dangerous voltages on the conductor rail. So we used to turn off the conductor rail and then fit short circuit straps, which is the equivalent of earthing on an OLE system. We need to do that because otherwise trains can run in from live sections, and they can, through the buzz line connections on the train, they can liven up the conductor rail. Someone could make a mistake in the control room. So effectively, that short circuit strap gives the integrity of that isolation. It means that you cannot have dangerous voltage on that conductor rail, which means that when the person issues the permit to work, everyone knows within that set area it is safe. There is no chance of that conductor rail becoming live. To do that, we used to have to take all that kit and picture to site. So we had a tester, make sure that before we do anything, the conrail is de-energized. We then put a short circuit bar down, because then that protects the person actually kneeling down in front of the conductor rail fitting the short circuit strap. Rubber gauntlets, the short circuit strap itself, wire brush to clean the underside of the running rail and the conrail, and goggles. And if everyone followed that every time in the right place, that's 100% safe. Because you're testing, you've got a short circuit bar down at the side of you. Even if something happens in that time, you're then connecting your short circuit straps together. Unfortunately, there have been a number of incidents over the years where people haven't always followed the right process. And having done it several times, I know it's a pain in the backside to take all that stuff to site, which might not be right by an access point. I get that. But I still worry and wonder how people can kneel down in front of a conductor rail that may be live and offer up a short circuit where the only thing that's going to happen is there's going to be a big arc that will ultimately cause them a load of harm. So the whole process, what we're doing now is we're removing all of those risks. We're removing all of that manual handling. We're removing all of that access down the track. So we are fitting negative short circuit devices. The negative short circuit device actually carries out the same function as a short circuit strip, but it's got even more functionality that's really useful. The local control panel, so you can see a person, they're operating a panel. It's always by a position of safety. It's always by an access point. So there's no reason why not to go there. And actually the operation currently is by switching a switch, which is safe. It's literally a small switch. So it cuts down on driving, it cuts down on slip, trips and falls, and actually it increases time as well, because actually going out fitting short circuit straps takes some time to do. Clicking a switch, putting the padlock on it is very, very small compared to that. So we've improved safety, we've improved actually the integrity of the isolations, because we always know we're fitting the short circuit in the right place. And we're providing more time, which may be enough to do some more work. Just really depends on the length. But in Wessex, for example, there are times we get 2.5 hours to do work. If we can give another 30 minutes, that's a significant increase in the amount of time for that work to take place. Even if it just means there's a little bit more time to stop people rushing. It sometimes means we can do 2 welds instead of 1. It sometimes means that we can do those other things. That means we can mitigate having to put speed on in the morning when we open up, which improves performance, which is what we're all about, funny steel boxes on steel wheels. So at the end of, so all of this is funded through a separate pot of money that the ORR agreed to provide to Network Rail. And of course, as challenges come for funding, as in any line of our business or any business, we've had to sort of change our vision as to where we want to get to. So by the end of CP6, overall we'll be about 50% coverage. CP7, we want to have covered all of the substations, but maybe not the midpoint. And then CP8, we will get where we wanted to, effectively, probably in CP7. So unfortunately, there's been a little bit of slippage in terms of our vision where we wanted to get to. Doesn't mean that the pressure is from the people on the ground to do this. We've had a number of safety workshops at the part of the start of all of this, actually talking to people who fit straps, talking to people who will be involved in this process. And our problem has been the challenge to roll it out quickly. It's not about having to force people to use this. People really want, they can see the benefit to them and also for the work to actually carry this out. You might have heard of a device called a hook switch. Hook switches are locally operated devices. We've still got lots of them in Southern. They're a very, very simple knife switch, not the most sensible. We wouldn't design that like that today. And what we're doing is where we've got midsection, with those that are regularly used, we're converting them to what we call a control track switch, part of our smarter isolations, which means that the ECO can operate them. So people, again, don't have to go out and site and operate them, they're operated as part of switching off the circuit products. And all of this is pretty much an evolution. I'm a great believer of incremental improvement. If you always wait for utopia, you never get there. So we've always had a journey in our vision about where we wanted to get to. So ultimately, the utopia is being able to have an ECO to operate not just the circuit breakers, not just the CTSs, but operate the NSCDs. And then using one of these mobile phones to be able to lock out on site those devices so they cannot be operated by anyone else. That saves having to go to local control cabinets, it saves having to put padlocks on things, and it makes it even safer, even quicker. So we've got a number of different tools. We've got a busbar NSCD, which I won't go into too much detail here. But we've got no one solution fits every application or every site. So what we've got is a number of tools that we can choose the most appropriate, the most economic to fit in a particular location. We're looking at, we've now got integrated track circuit breakers and NSCDs, which means that if we're coming up for a track breaker renewal, we almost get two for the price of one. We get an NSCD almost thrown in for nothing. So it's looking at building those new tools up. We didn't have that when we started. In Wessex, we started this about 5 years ago. We didn't have the busbar NSCD, we didn't have the integrated DC breaker NSCD, we didn't have remote secure. But if we hadn't started, we wouldn't have saved all of those straps. There's hundreds of thousands of people going out, or occasions of fitting straps we've saved and de-risked the business by having NSCDs. And the other thing an NSCD does is it provides, through its interlocking, it stops the operator making a mistake as well. So when the NSCD is in the short circuit position, it locks out the operation from the ECRO. So even if they make a mistake, it doesn't do anything. And that's the other thing that provides a greater level of compliance with things like electricity at work rigs. We're looking again at an evolution, instead of having a local control panel for each site, to actually have a consolidated control, where we actually control a number of sites from one location. Why do that if we get the ultimate of the remote secure? Well, remote secure is not a done deal. It's one of my current battles about trying to progress that through the necessary safety arguments to prove that we can mitigate risk and make this even safer. So consolidated control is another tool in the toolbox. Actually, for some of our older sites, that might be the most economic way of doing it rather than remote secure. So again, there's utopia and there's actually consolidated control that still give us massive benefit. And we've got a tool in the toolbox. I talked about decarbonisation in the vision. So we've got a number of areas we're looking at. So we're looking at helping. There are some possibilities that we can help fund offshore wind generation, for example, and buy the energy from that, even though it's distributed through the national grid. That can still be cheaper than just buying from the national grid. We're looking at energy generation ourselves, so we're looking at things like solar, feeding our own 33 kV traction ourselves. And we're looking at energy storage, so there's a level of, can we use the energy we get even more smartly? So almost like a storage heater in your home, if you've got storage heaters, it uses energy when energy was available, and lets out heat in the day. So that's a form of energy storage from some time ago. Can we do similar things on our network? So at the moment, there's a little diagram that shows how we feed our electrification system. So from a power station, goes through the national grid, goes to a grid substation, we take a number of supplies, and then we've got our own generally 33,000 volt line side cable that connects to all of our substations. And that source of power could be anything. It could be nuclear, it could be wind, it could be solar, it could be coal, it could be gas. We currently have a tariff where we buy 100% renewable, 100% from nuclear. So we don't actually pay for any energy that comes from a gas or a coal or a biomass generator. We are looking, I mentioned the thing about offshore wind turbines, solar PV, hydro, that are not on our infrastructure, that we can connect to our infrastructure through the national grid and distribute to our own substations. But we're also looking at, can we actually build our own solar or wind renewable energy and feed it into our high voltage network? We actually are the first railway in the world that use solar for traction purposes in Wessex, albeit in a very small scale at Aldershot. That was more a proof of concept. We nearly had a 4 megawatt, which is quite big, solar farm in Sussex that was going to feed our 33 kV network. We've learned quite a lot of trying to work out where the sweet spot is between size of solar installation, because the bigger the solar installation, the lower the percentage, if you like, of connection cost is. But we need to be able to use all that energy. One of the other problems in this country at the moment is we cannot often export back to the grid, because there's a big issue. That's one of my topics I can talk for hours about, which I won't, you'll be pleased to know, about the strategic way that we have our power system in this country. So there are whole developments in London, for example, in West London, that can't go ahead because the DNO cannot provide power to that new installation for about another 10 years because of the deficiency in the grid distribution system. And we are almost facing that same sort of issue ourselves, albeit in a different way, that we can't export for that very reason. So we currently got two trials, one of which is further progressed, which was Weymouth is a classic example where all of the trains in Southern largely are regen enabled. So when they break, it regenerates the energy back into the conductor other trains use. As you get further out from London, there's less likely to be receptive load, so that energy is just wasted as heat. Weymouth is a classic where a train's going down Bingham Bank into Weymouth breaking for quite a long time. There's no other train in the vicinity because that's the train that goes back up the hill a few minutes later. So we're looking to put in, and it's not battery anymore, it's probably alternative energy storage to grab, take that regen braking that would otherwise be wasted and help power the train back up the hill to A, reduce the amount of energy we use, but actually it also has a system benefit of almost providing a mini sub at Weymouth, which is exactly the place we really would want to have a substation. So there's lots of benefits in looking at energy storage. What can we do? Can we peak top? Can we reduce the cost of our electricity supply by actually having a lower maximum demand? And when we're actually under that maximum demand, storing that energy for using later? A bit like the analogy of the night storage heater. And then, so at Guildford, there was going to be a flywheel. I think this one's was always a little bit more touch and go whether it had a business case, but actually flywheels might be the solution for Weymouth. One of the problems with batteries is, as everyone's got a phone or a NiCad in the past, you know that they've only got a certain number of charge-discharge cycles before they don't hold as much energy or they don't last as long. Weymouth would be a classic where twice an hour we'd be going from charge-discharge, 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 which is not particularly great for a battery. So we're looking at alternatives. One of the alternatives is flywheel. We're looking for supercapacitors, and there's all sorts of other innovation taking place in the market for energy storage. compressed air, liquid sodium. There's all sorts of research going into how can we get away from batteries for energy storage because of the downside, the cost, the weight, and the duty cycle, if you like, of a battery. How can we improve that over the life? So I mentioned and talked about Aldershot. It's a very, very small size in terms of providing a train. If you think a 12-car train on Southern is about 3 megawatts, and we've got 30 kilowatts. So it's a very small proof of concept. But just even doing that helped us to learn a great deal about the ways of connecting the various options we've got, because we wouldn't be doing any of this if it doubled the cost of the electricity. We have to find a way of, yes, it's great having renewable energies. Yes, it's great being able to show how we're meeting the carbon challenge. But if it costs us a lot more money, no one's going to thank us for that. And then the Selmeston was the larger 3 to 6 megawatts solar, which actually hasn't happened because there were a number of technical and commercial issues that really got to a point where we couldn't take that forward. But out from Selmeston, there is a project in Network Rail looking at where would be the best place on our whole system if we were going to put in 6 to 10 megawatts of solar or higher. Where would we want it? And then instead of having applications for this particular company at Selmeston going, tender to say, can someone build us 10 megawatts of capacity at, I don't know, Tunbridge somewhere, or Woking. I don't mean right in the middle of the town centre, but you know what I mean. So I've talked about 21st century third rail electrification. There's an amount where people have actually tried to say that we can't, and I've just realised that I need to go back to a slide I went over too quickly, I think. We're about 84% electrified in Southern. We're one of the regions that has the lowest number of diesel passenger trains because of a level of electrification that started in 1915 and went through to about 1993. Clearly, there has been some worries about the top contact ground mounted conductor rail in terms of going forward, in terms of both what ORR and in terms of even Network Rail would want to do to progress going forward. What we started to do is try and move away from those absolutes and trying to look at a true CSM style risk of what can we do to new generation third rail electrification. So we're already going to be making it much safer for staff because we're actually saying that with safer, smarter isolations, with the way that we plan how the isolations are taken, we minimise the risk to anyone getting into contact with a live conductor rail when they're working on the track. We want to show how we're helping improve the risk or decrease the risk for passengers and trespassers at stations. So that's one of the key areas where, unfortunately, there are times where people are either having had too much drink or kids or whatever decide to cross over the track, jumping down from the platform and not using the authorised bridge or subway. And sadly, if they are drunk or if they just fall over, it doesn't always end very well for them. So is there a way that we can improve the safety of stations by having a normally de-energised conductor rail that only is energised when a train comes into the section, or leaving the rest of the system pretty much as it is? We want to look at 25 kV because when I first started 38 years ago, I did do a load of OLE design and some of my structures are still there in Ipswich Yard. So I'm an E&P engineer, I want the right solution. Sometimes I think that will be DC. If I want to go 140 mile an hour and I want double-decker trains and I want a lot more power of the trains, then it's not the right solution. I want the ability to choose what that right system is that provides the output. So upfield line as an example, currently diesel service. If 25 kV came out at the cheapest way of doing that for the system and industry, why wouldn't I want that? If DC comes out, much cheaper, why wouldn't I want that? And of course, with all of that, there are then all the other options. So there's battery. Can you actually get a battery that would take a train all the way from Hurst Green down to Upfield and back again? The answer is no. So what do we do? How do we get that energy in the battery? Maybe a 2-car would be possible. To get a 12-car and the number of megawatt hours you need to get into that train to power it for that journey to Upfield and back is incredibly difficult. And even if you talk about rapid charging, even if you talk about putting in charging at places like Upfield, you then need to have a set of batteries that sit by the side of the track because you need to be able to pour that energy so quickly into the train. So that becomes quite expensive. And of course, as anyone who owns a Tesla when they were catching fire knows, when you've got that level of energy, you've got a fire risk. You've got a massive amount of energy that if you don't manage that energy, that heat you get when you charge and discharge a battery, it don't go well. But again, if a battery is the right solution, such as, for example, Marshalling, which is a maybe 2-3 car operation which will run from Eastbourne and can charge off the existing infrastructure, that's far more feasible. So battery might well be the right answer. And it's about tools in the toolbox. Hydrogen, we've looked at. Well, hydrogen is a bit difficult because it's not a very energy dense fuel, so you need lots of space. We don't have hydrogen generating plant in this country particularly, and the last thing you want to do is to be burning fossil fuels to create hydrogen, because then it's just so inefficient, it's unbelievable. So hydrogen tends not to work in the south anyway. Then we've got battery electrification hybrid, and potentially electrification battery diesel hybrid for some lines. So no one's saying that's out of the question, but we need to look at the lengths, the duty cycles. If the train's terminated and has to turn back, can you provide battery charging capacity if you're not providing fixed electrification? All of this goes through a business evaluation. What's the most cost effective? Then there has to be a safety case argument put together. So using sort of CSM style arguments. And all we know is that out of all of that, for example, Upfield, the answer came out, DC electrification third rail was about half the price of OLE. And if we can show through our risk assessments and our risk arguments in CSM that we can manage risks in station areas, we've had loads of conversations with the ORR, and whilst they've not said yes, they're certainly not saying no. So there's more work to be done there. Almost until we get the money to build one of these, we're not going to get the final answer because we won't be able to push it through that final point. But we are undertaking a trial of the platform switching scheme that will be in Tolworth. So we are going to press ahead with that. So it's a tool in the toolbox. What that diagram shows is normally the section in the station area, and it can cover a level crossing if that's by the station. Station will be de-energised. When the train comes in, it'll be energised. So if someone decides to jump down at the point the train's coming in, then sadly it won't work. But it's a way of trying to show how we're minimising risk, we're treating risk, and how we're trying to manage risk. And the crux with all of this is to keep it simple. So it won't be associated with signalling. That's no disrespect to my civil engineer colleagues. It just means you normally add several zeros to the price of anything when you interface with a signalling system. So this will be a really simple, cheap and cheerful system that hopefully will be really reliable. The bits of kit, we've already got the bits of kit we need to use for it, and hopefully we will be trialling that at Tolworth on a live system. As an industry, what we're also looking at saying is every train had a small traction battery on it. Then we could actually normally de-energise every station platform because we wouldn't need to switch it. What we said is for a low traffic use, it's sustainable to have a switching device. But when you get to somewhere like Clapham Junction, far too many trains. If every train had a small traction battery on it, that length of conductor rail at Clapham Junction, for example, could be normally de-energised. The train pulls in, pulls away on battery, then back on the conductor rail. So it doesn't need to be a very big battery or energy storage medium. So we're working with industry, we're working with the train leasing companies, with the RR and DFT, because all of this adds a bit of cost and weight to the train. But as an industry solution, which is really where it comes back to that system again, doesn't it? We should be looking at, rather than saying, well, it's not my problem, it's trying to get that best, lowest cost solution, because no one's going to thank us for putting extra money into the industry, especially at the moment. And of course, all of this will then have if we have a disaster, we'll be able to re-energise the conductor rail through one of these control switches. So, to summarise all of that, we've got a load of exciting innovation. We've got new products. We've got a new conductor rail we are going to try. We've dabbled with aluminium, stainless steel, composite conductor rails in the past. It's gone rather badly. So we are looking with a different company to develop a lower resistance but more resilient conductor rail. That's something we're doing in Southern. If it's successful, we will of course share that with Merseyrail and all the other DC. But so we're not waiting for anyone. We're pushing that forward. We've got new equipment. We want to go to solid state HV switchgear. We want to go for a better type of DC switchgear. We're talking to manufacturers, trying to generate that not just interest, but that development opportunities. What can we do? How can we drive this forward? Not just waiting and doing what we've always done. How can we always say, can we get a better DC breaker that's quicker? If it's quicker, it has less damage out on the track, because the longer the short circuit's on, the more the arcing will take place, the more there's a risk of a bigger defect in the rail if there's a piece of metal or something between the running rail and the combo. We want to improve the safety, so we're on that journey. We've got safer, smarter isolations, where the whole philosophy for smart is trying to fit possessions around isolations, not isolations around possessions. Maximise time, minimise the people going out having to switch things. And we want to look at these challenges of where we've gone through the hierarchy. We've got new electrifications, infills, whatever it is. We want to be able to, where that is the right thing, the safety justification shows it, the economics show it, we want to be able to take that forward. So ultimately, this is all about the outputs for the passengers, for the customers. They don't really care if it's an LLE train or a DC train, they just want it to go. There is a level of people care about the amount of carbon in the environment, absolutely right. But they also want to have a reliable, sustainable, economic, affordable train service. And all we're trying to do is to push forward those developments, always asking, always taking that to the next step. So the future is exciting, as I keep saying. It's great to be able to talk about it, because sometimes, you know, the Southern can be quite insular. We knew what was going on, did other people. And part of the really nice thing for me to be able to have an opportunity to speak to people like today is try and explain and show how we're not just sitting with what we've always done, doing what we've always done, building things we've always built, but actually taking this to the next level. So, that's it. Has anyone got any questions? I have left time for questions, I think, hopefully.
Thanks, Nigel. Really interesting presentation. My question was, my name's Toby Johnson. I work at RSSB in the infrastructure standards team. And one of the things that we've recently done is done some consultation with some of our stakeholders around one of our standards related to gauging. This relates to what you were talking about in terms of what is the best solution. And in our standards, we tell the infrastructure managers, or if it's a new build, the builder to reserve the space for OLE, and the stakeholders' response is, why on earth would you do that in a third rail area? Why? That's just adding in additional cost to the railway that you don't need, because you've already got electrification there. You'd never put in OLE. But from what you're saying there is a possibility that a third rail area might not always be third rail, and perhaps it is a good idea to reserve some space.
I'd never say never. Whilst the DC system can provide the outputs needed to run the train service, I'd argue that why would you want to go to OLE 25 kV option? And actually, all the sorts of work that people have done in decarbonisation and the strategy for how the country will be managing decarbonisation, where we've got loads of diesel routes that need to be electrified with OLE, why would we then go and do something on Southern? And I'll just give one quick example. At one point, things like electric spine, for example, we were going to have 4 or 5 years worth of disruption for our normal passengers, give them back the same train with a pan on top and the same timetable. And there isn't really, as a passenger, there is no benefit in that. So I think the answer to the question is, can we compromise on clearances so that we get a economic, rather than building everything so high that's a stupid cost when we're never going to use it, but get to a point where we can compromise on reduced clearances and say, actually, that's okay for this type of bridge, for this type of network, given that it may not be, if ever, it will be electrified at 25 kV. I think you can see some structures in the past where you go, why have we gone and built them quite like that? Is that the right place to put our money? So I think I can never say the answer will be never, because if people wanted to, I don't know, go from Woking to Southampton at 150 mile an hour, DC won't provide the right answer to that. But actually, if all the time the DC can, at 100 or even 110 can provide the capability to support that train service, why would we do anything else? Freight's a more complicated argument, and freight's also bounded by what do you do with diversionary routes. So if we only had one electrified route, how the heck would we ever get to do maintenance on a night time? It's already in Wessex, as an example, almost impossible to get the access that we need with the level of train service and the level of freight at night. But at least we can divert freight from Southampton via Laverstow back to Basingstoke. If we only electrified one of those, then unless the freight company also had diesel locos as well, then it will put even more stress on access. So we need to look at that whole thing again, don't we? So the answer to your question, we had agreed in the past some reduced clearances, and I think Richard Stainton was working on trying to publish some of that guidance, that where it made sense to have a level of minimum clearance, but without having to put in, which actually doesn't cost that much more compared to having, you know, massive extra cost on structures which we might never use in the life of that structure.
Thank you.
Hi, Nigel. I work for Visual Rail Finance Construction and lead living engineer on London Underground IT renewal projects.
Yep.
I really enjoyed that, so thank you very much. My question is about the NLCBs.
Yep.
It's fascinating topic itself, because obviously it improves the safety on track itself, and obviously everyone who works on electricity. But as a system as a whole, does it have some sort of fail-safe mechanism that or you have a secondary method of testing that actually the current will have been discharged and it's safe for workers to go on track?
Yeah, so the device itself has got integrity built into it. It will check whether the conduct rail is live or dead before it operates. So if the conduct rail is live, it won't operate. And there are indicator lamps as well for the people that are operating the control panels. But on the basis that that's dead and those devices operate, we still then ask all of our COSs, the people in charge of the site to work, to actually test the conduct rails, to make sure they're in the right place, and that final check, that test before touch, to say, even though you've got a permit to work, to test to make sure that you are safe where you are actually working.
And then talking about the future development of the LSCDs, you were talking about the app and the remote access.
Yep.
So obviously that is a reliance on the mobile network signals and
Yep.
like internet access. So do you gonna have some sort of secondary system in case of, let's say the network goes down?
So we already have a level of mobile network that's alongside every piece of railway anyway, that is there for the train and the train management systems on it as well. So there are, where we don't have public access mobile, there's talk about using that limited but secure mobile systems actually right by the railway. Because yes, if you've got no mobile network, it ain't going to work.
Yeah.
The alternative is we put little mini fixed points in that are also possible, that we put a land connection into a point where it then provides a mobile signal, where we know that those people are going to be congregating for that event.
It's in the online.
Right, so we've got some questions online as well. So the first one, are Southern DC E&P engineers taking interest in professional registration with the PWI? So the answer is yes. I've actually been helping the PWI develop a course for DC third rail engineering, which the first one's going to be running in November. And I very much see that as the way forward, and attracting people from the E&P community to use those various courses and learning development to take things forward through the PWI. So the answer is yes, I believe so. Am I able to expand on the aluminium stainless composite section problems? Aha. So I will say yes, but this is my view. And the whole point of the trial is to see whether I'm talking a load of nonsense, or whether there is a level of sense in it. So what we know is that so the current designs of composite conduct rail are clamped to the track because the conrail's not heavy enough to sit as a beam as a steel conductor rail. And it's not strong enough to be able to withstand things like buckling as much as a steel conductor rail can. Now, we know that and excuse me, don't hit me, but where the track is not in the greatest condition, there is accelerated wear on the aluminium conductor rail in those areas. Now, if you go to a steel rail sits as a beam. We have the pots, the insulators as supports, but if the sleeper drops, the conrail stays horizontal as a beam. So as far as the slipper is concerned, it has almost a perfect surface to run on within reason. One of the considerations that we've been thinking on is if you clamp that conductor rail to the track and the track depresses, you're then creating a non-level surface for that slipper. Therefore, you might not be having a flat contact between the slipper and the conductor rail. So there might be some, well, not saying it's massive, but you might be getting some micro arcing underneath that slipper that's then causing a more rapid acceleration of wear on the top of the stainless steel. It may be partly mechanical. We're also looking with this newer design to change the grade of stainless. Stainless comes in many forms and many grades. And the one we're proposing, the company are helping us to develop this, say that it has a number of properties that should survive that accelerated wear much greater than the current designs of stainless. So the intention is the rail is self-supporting, so it doesn't have to be clamped. It uses standard components, so we'll be using standard pots rather than having bespoke fittings for it. And we're hoping that we can make it rigid enough that it will be a beam just like a stainless, just like a steel conductor rail is.
Not on underground, we are using composite sort of aluminium on certain sections on the district line where you have aluminium and on top you have cap section where the
Slipper runs.
Yeah, where the collector shoe runs on, so obviously that is still capped, and obviously where it wears off, you have to replace it. But
So
it's still tied down. I don't know what sort of length of sections you're talking about on network ground, but on London Underground, I think maximum 190 meters or 200 meters sections, they have still like an angle which I'm talking about to
Have exactly the same problem where they have particularly bad track, they have particularly bad Conrail wear.
Yep. So, you know, if you had slab track, for example, I suspect we wouldn't be getting the same difficulties with the current designs of composite. Just to get a level of how bad this has been, we tried it at Woking on the Upfast, and it was a relatively short length, but that lasted 2 years. Design life of 40. Steel rail lasts a nominal life of 75 years. At Clapham Junction on the Sussex side, on the up main fast into Victoria, it lasted 6 months. So that's why currently it's not sustainable. It's got lots of advantages, both energy and weight and way that we can put it in, but not with that sort of length of life. And it sounds like the underground are having similar issues. But so the other thing is we do share developments with LU. So when we've got this new design, if it actually works, we'll be sharing that as well. Why wouldn't we? Am I okay for time? I've got a few more questions, or
Is that it from online?
I've got one more here. What?
Same.
It was the same. Yeah. So I think that's all the questions.
Coming.
While that one's being typed in, do you have many problems with track fires?
So we can do. I think there's one of the things that having a third rail conductor rail leads to is there needs to be good housekeeping. So, you know, if we've got a load of debris around a ramp end, there will be a fire. If you let loads of debris, leaf, dry leaf, other material build up not too far from the Conrail, all it takes is one spark, and then there is a fire. Generally, and I do say generally, when all of that takes place, and the other thing is wooden sleepers. There can be times where you get a severe arc at a ramp that actually sets a fire off or starts the sleeper from smouldering, and that's to some degree system design, because that's where we are actually gapping a train and there is a severe arc that's being pulled by the train. But we can put arc shields actually on that ramp end to try and minimise that risk, and obviously it also tries to mitigate the risk of that arc jump into the running rail as well. So I think if it's managed, it's manageable. If people, that sounds obvious, but where people let that debris build up or on top of it, then even at Waterloo Station, for example, it's in a train shed. But due to the movement of air around the station with trains pulling in and out, you do get leaves and other debris, people's newspapers, underneath the conrail, and it's dry, it's fine. Then it rains and a train comes in, drips water onto that area, and then the danger is you start getting a little bit of leakage from the conductor rail that starts to cause either steam or smouldering. And again, it's not a fire per se, but a driver will report it, or a member of the public will report it, and then that platform is shut until that debris has been cleared. But there's always a precursor of debris, inflammable material, or something that's around that could have been managed.
I also think probably there's a lack of appreciation that conductor rail problems are silent service stoppers. A lot of people don't consider that could be the problem that does stop the service.
Yeah.
Particularly the same issue in the underground.
Yeah. So for example, when people are putting stressing kit on running rail, the size of the stressing kit normally means you need to move the conductor rail up and out over the pots a little bit, which is fine. It's absolutely designed and capable of doing that. But if then people forget to put the conductor rail back in the pots, it doesn't go very well.
Okay. That's
Okay.
Sure. See you later. Thanks.
All right. Right, no worries. Thanks very much, Nigel. It was an excellent presentation, very interesting presentation. I think it's been many years since there's been a presentation on the conductor rail. I really like the vision, zero harm, 100% service delivery. It's what everybody wants, really. And also, of course, you do have to get the people that both work with you and pay your wages to work for you as well. So, in terms of development and appreciating where the engineering needs to go, not just on the tracks itself, but how you get the power delivered to you, get the power stored, is a key consideration for people going forward. I also thought that, I know, because being a person that did use short-circuiting devices many years ago in Southern myself, it is quite a scary experience. If it does go wrong, that the amount of harm that can happen is not worth. It's not worth suffering for when you can have these new safety devices that you introduce, and I do commend you for going forward and introducing those. So in time-honored fashion, can we give Nigel a round of applause, and thanks very much for the excellent presentation.
Okay. Thank you very much for joining, and our next meeting will be in October, and hopefully the subject should be about the recent works done at the Moon Viaduct in Oxfordshire. I think some of us might retire to Red Line afterwards for a quick drink, and enjoy yourself on. Thank you very much for joining.
Thank you, everyone.
Cheers. Thanks.
Thank you.
Before we all break up, just